Right, for lab 1, the focus was constant velocity, and I observed a basketball rolling in the view of the camera and back out. The principle used was Newton's second law, which is the change in velocity over the change in time, and that equals the net force divided by the mass. And we assumed the net force was equal to 0 for the model, and the model made relatively accurate predictions that matched with the observed motions. And the purpose of this is to observe the motion and use known info like mass, change in velocity, and change in time to get data like the net force, which is otherwise unattainable by just simply observing a motion. This was the experimental information that was needed before analyzing the video in Tracker. And the system was the basketball with a mass of 0.595 kilograms and a diameter of 0.239 meters. And the surroundings consisted of everything else, and it had a net force equal to 0. I decided to place the origin at the center of the ball, and the ball rolls to the left of the origin in the negative x direction. Important information was captured through these frames, such as initial time and position and final time and position. This information was used to calculate the initial velocity right here, and also it was used to create a model. In the model, we inserted key information such as the mass of the system, the initial position, and the initial velocity. And remember, the ball was rolling in the negative x direction, and this explains the negative velocity. And the F-net, like I said before, is equal to 0. And as you can see, the F-net is used right here in this equation to calculate the velocity. However, we know that the velocity is constant, so that means the final velocity is equal to the initial velocity, and the ball's mass doesn't actually matter when it comes to this. And this is what the model looks like when you run it. Okay, and as you can see, when you put the experimental and the model up side by side, you can tell that they're extremely similar. There are only slight variations, and this could be because of a variety of errors, such as the ball not rolling in a perfect line, or maybe it wasn't rolling at a constant velocity the whole time. And the questions that are needed to be addressed are, what if the orientation of the axes were changed and the velocity would become positive 1.03 meters per second, and it would move in the positive x direction? And is there a way to know how many pushes and pulls are added together to make the net force equal to 0? And the answer is no. The only information that we do know is that the net force is equal to 0, but we aren't sure exactly how many add up to equal 0. And that's all. Thank you.